In this lecture, we try to solve one example based on the modulus and argument of complex number. So the example is find modulus and argument which is in the principal value of the following. The first complex number is 2 plus I root 3. Second complex number is 2 minus I root 3. Third complex number is minus 2 plus I root 3. And fourth complex number is minus 2 minus I root 3. So there are four complex numbers. We want to find out the modulus of these complex numbers as well as their argument. Principal value means we have to find the value of theta in between 0 to 2 pi. So let us first take it's the solution. We have to find modulus and argument of the following complex numbers. X plus iy is equal to 2 plus I root 3. We are taking the first example, this one. Now here x is equal to 2 and y equal to root 3. So we know that modulus r, which is given by mod of z, which is nothing but the mod of x plus iy. But mod of xy is root over x square plus y square. But x equal to 2 and y equal to root 3. So let us put its value root over 2 square plus root 3 square because x equal to 2 and y equal to root 3. Therefore, 2 square is 4 plus 3 root 3 square is 3. So root over 4 plus 3. Hence, the modulus of the given complex number 2 plus I root 3 is equal to root of 7. And its argument theta is equal to tan inverse of y by x. Since theta is equal to tan inverse of y by x in the first quadrant, since the value of x as well as the value of y both are positive, so this complex number lie in first quadrant. So its argument theta equal to tan inverse of y by x. So let us put the value of y is root 3 and the value of x is 2. Therefore, modulus of z, which is equal to r, is given by root 7 and argument of z is equal to tan inverse of root 3 by 2. Now we can show this complex number in the Argand diagram. So this is the complex number 2 plus root 3i and this is its modulus and this is the argument theta equal to tan inverse of root 3 by 2. So this is the modulus and argument of the complex number 2 plus I root 3. Similarly, if we take the example number second, find the modulus and argument of 2 minus I root 3. So here again x plus iy equal to 2 minus I root 3. So what is the modulus? Modulus r equal to mod of z, which is given by mod of x plus iy, r which is root over x square plus y square. In this case, the value of x is equal to 2 and the value of y equal to minus 3. So this is, if you see in the Argand diagram, this is origin, and this is the number 2 minus root 3i. This is a complex number. So it is in the, this is the first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So these numbers lie in the fourth quadrant. And so if you see the modulus is nothing but 2 square is 4 and minus root 3 square means 3. So this is nothing but 7. So modulus is 7. Argument which is equal to theta, which is given by minus tan inverse of y by x, because in fourth quadrant, the number is lying in fourth quadrant, and in fourth quadrant, the theta is equal to tan inverse of y by x. Hence, minus tan inverse of root 3 by 2 are, sometime we can also write down modulus in fourth quadrant by 2 pi minus tan inverse of root 3 by 2. Therefore, modulus of the given complex number mod of z equal to r equal to root 7, and argument of the given complex number is minus tan inverse of root 3 by 2, or sometime we can also write 2 pi minus tan inverse of root 3 by 2. Now we take the example of the third question of the first example. So we find out the modulus and argument of minus 2 plus I root 3. So now if you see this number is lying in second quadrant because the value of x is negative and value of y is positive, which is lying, this is the real axis, this is imaginary axis, and this is the point minus 2 plus I root 3. So in the same manner, we can find out the modulus. Modulus r equal to mod of z, which is equal to root over x square plus y square. So minus 2 square plus root 3 whole square and whole under root, because x equal to minus 2, y equal to root 3. So it gives us again mod root of 7. So modulus of r equal to root 7. And argument, since it is in the second quadrant, so in the second quadrant, argument is given by theta equal to pi minus tan inverse of pi by x, where y is root 3 and x is equal to 2. Hence, the modulus of our given complex number is root 7, and argument is equal to pi minus tan inverse of root 3 by 2. Now, let us take the last part of this question. So this is what? It is the root 7, and this angle is theta equal to pi minus tan inverse of root 3 by 2. And let us take the last part of this example number 1. We want to find out the, oh sorry, this is both are minus sign. Fourth value, we want to find out the modulus and argument of the root x plus I y equal to minus 2 minus I root 3, which is given by, so modulus is given by just minus 2 whole square plus minus 3 whole square and whole root, which because x equal to minus 2, y equal to minus 3. So we have again mod of z r modulus of r is equal to root 7, and argument theta is, since this lie in the, this is real axis, this is real axis and this is imaginary axis. So theta is equal to this, and this is the point. This is the point. This is theta, and this is nothing but root 7. Right. So this is our this total angle. This because it's pi plus. This total thing is pi, and this is plus. So this and not this angle. This angle. This is whole theta. Pi plus this from this to this point. Pi plus tan inverse of root 3 by 2. So this is whole, this is pi, and this is nothing but root the tan inverse of root 3 by 2. So the argument of the given complex number is root 7. Oh, sorry, modulus is root 7, and argument of the given complex number is pi plus tan inverse of root 3 by 2. So hence we have already seen in this example, we have taken the 4 different numbers. Let me show you in this example. So we have taken the all 4 numbers. This is 2 plus I root 3 minus 2 plus I root 3 minus 2 minus I root 3 and 2 plus 2 minus I root 3. So we have taken this 4 number. So definitely the argument of all 4 number are same, root 7, and root 7. But the angle modulus of all four numbers are same, which is root 7, but argument is different. For the this number, this is argument. For this number, this is argument. For this number, this is argument. And for this number, either this is argument or this whole is the argument of the given complex number. So even though the modulus of the some numbers are same, but argument will be different. So if you want to identify the two complex number are different, so if the modulus of the two numbers are same, maybe same, but their argument will be different. So that's it in this lecture. Thank you.